Welcome to the binomial theorem. So the binomial theorem is a easier way of working out the expansion of a binomial rather than having to remember Pascal's triangle. In particular, if we wanted to get all the way down to the 20th row, rather than having to write Pascal's triangle out for the 20 rows, we can actually use the binomial theorem. And so we can write it as NC0, which on your calculator is the button above the divide sign. So you'd go shift divide. And the value in front of each value of the first coefficient is NC0, the second one is NC1, the third one is NC2, etc., all the way to NCN. So you can see there the expansion of x plus y to the n. Now we can write NC0 or we can put it in a bracket N0, N1, just to make it easier for us to write without having to write the C in there. So if you were to do this using x plus y to the 5, from before the Pascal's triangle was 1, 5, 10, 10, 5, 1, and we can change that notation, so we'd get 5C0, 5C1, 5C2, 5C3, 5C4, 5C5, and if you did that on your calculator, you would get 1, 5, 10, 10, 5, 1. And so that's what you get. So in front of x to the 5 is 5C0. Notice, like we have done before, the coefficients of the first term, so in this case the x, it goes down in powers, and the coefficients of the second term go up in power. So it starts at x to the 5, then x to the 4, x3, etc., where the y starts as y0 becomes y1. And if you put those on your calculators, that's how we get the expansion, which is hopefully a lot easier than remembering Pascal's or having to write Pascal's out. The formula is for NCR is n factorial, this is how the numbers come about, n factorial over r factorial times n minus r factorial. That's why the last lesson we actually looked at factorial notation. So we're just going to confirm that by doing 8C2 and plugging it in to that and proving it gets 28. So on the top, the n is 8, so you get 8 factorial. The r is 2, so 2 factorial times 8 minus 2 factorial. That is 8 times 7 times 6 factorial over 2 times 1 times 6 factorial. The 6 factorials cancel. You get 56 over 2, which is 28. Obviously on your calculator, put that in and you will get 28. Let's use our new binomial theorem to do the expansions. We're going to find the coefficient of x to the 6 for the first one and x cubed y to the 5 for the second one. So for the first one, the expansion of 1 minus x to the power of 10, if we went all the way along until we got the x to the power of 6, because that's what we're after, that'd be 10c6 minus x to the 6. So the coefficient of x to the 6, if you do 10c6, is 210. For the second one, x cubed y to the 5 in the expansion of 2x plus 3y to the power of 8. So if you went along to get the y to the 5, that'd be 8c5. So the x would be to the 3, so that's 2x to the 3, 3y to the 5. And you can therefore multiply that out. So 8c5 is 56. 2x cubed is 8x cubed, and 3y to the 5 is 243y to the 5. Gives you 108,864 x cubed y to the 5. Special cases to look at. So if we just work through our first three, so NC0 is n factorial over 0 factorial n factorial, which is always equal to 1. And we know that from Pascal's that the first number in the line of every Pascal's triangle is 1. NC1 is the second one in, and that is n factorial over 1 factorial over n minus 1 factorial. And using our factorial notation, we get n, and that would be the second number in. It's always the whatever n we're talking about. And the final one is NC2, is n factorial over 2 factorial, n minus 2 factorial. which gets you a half outside of n minus 1. Now, one little thing to remember is that NCR is the same as NC n minus R, because when you look, because it's symmetrical, if we come R in from the left, then it'll be n minus R in from the right, and therefore they would actually be the same coefficients. Let's use one of our rules to find the value of n, given that NC2 is 28. So NC2 is a half n minus 1. That equals to 28. Multiply the 2 across, get your n squared, and expand the brackets, get your n squared minus n equals 56. Bring it over and you'll notice you have a quadratic. Factorising that quadratic, you get n plus 7, n minus 8. So n is equal to minus 7 or 8, and because n must be positive, n equals 8. Thank you.